Hi team, welcome to this, which is the walkthrough for the Exampack for week 4. I'm going to go through each of the questions in turn. So we'll start with question 1. We've got that we need to expand and simplify. Now, expanding and simplifying, we should know straight away that we're going to draw a grid. Okay, so I'm going to draw a multiplication grid out. I should have P plus 9, P minus 4. So P times P is P squared. Okay, P times 9 is 9P. P times negative 4 is minus 4P. And negative 4 times by positive 9 is negative 36. Okay, so we get P squared plus 9P minus 4P minus 36. Now 9P minus 4P I can simplify. Get P squared plus 5P minus 36. Okay, because these two can simplify. 9P minus 4P is 5P. Lovely. This question is formatted slightly strangely, but I've got a fraction on one side equals to an expression on the other. I want to move this. The fraction is the thing that's going to cause me trouble here, so I'm going to times both sides by 3. Okay. By multiplying both sides by 3, I remove the fraction and I make my life much easier. So 8w minus 8 equals 3 lots of 4w plus 2. Now I need to make sure that I then expand my brackets. Okay, so the brackets at the moment are the next thing that's stopping me being able to solve this. 5w minus 8 equals, that should be 3 times by 4w, which is 12w. 3 times 2 then is 6. Okay, so I've done multiply there and multiply there. Now I want to get to a point where I've got all of my w's on one side. It doesn't really matter which way round we go. Okay, by habit I would normally put the smaller amount of w's over on the side where there's a bigger amount of w's. So I'm going to subtract 5w from both sides. Okay, that leaves me with negative 8 on this side. 12w minus 5w is 7w, and then plus 6 on this side. Okay. Now I've got the plus 6 is currently stopping me, so I'm going to subtract 6 from both sides. Extend my page. That leaves me with 8, negative 8, take away 6, it's going to get smaller, so it's negative 14 equals 7w. And now I want to divide both sides by 7. Divide both sides by 7 and I'll get that w is equal to negative 14 divided by 7. 14 divided by 7 is 2, but I've got that negative, so it's going to be negative 2. Okay, negative 2 for that question. For part C, it says factorise this. Now this one I've put in here to remind us of a key thing. Okay, we've got an x squared, so we're going to start thinking about brackets, but this is a special case. It's called the difference of two squares. If we've got a difference of two squares where we don't have the x term in the middle, normally we'd see something that looks like x squared, maybe plus 3x minus 49, for instance. Because we don't have something that looks like that, we don't have this term, we're thinking about the difference of two squares. That means that we're going to have x, and then we're going to have the difference of, which means we're going to have one positive, one negative, and then whatever the square root of this is, which is 7. Okay, so this is one where we should remember it. That's why it's 1 mark. Okay, it's too doing loads of working out for 1 mark seems strange. So we can see straight away we're going to do the difference of two squares, which means we do the square root of this first time, which is x, plus and minus the square root of the second term, which is 7. And this will expand out to get this. And I can check that if I want to by doing my grid. Now we can simplify this. We've got 9x to the power of 8, y cubed, and all of that power of a half. We should know that because we've got brackets, we're just going to expand all of these out. Okay, we have done this very briefly, but 9 to the power of a half. Okay, x to the power of 8 times by a half is x to the power of 4. Y to the power of 3 times by a half is y to the power of 3 over 2. Or you can put 1.5, that'd be fine. This isn't as simple as it could be though. What we need to do is know that 9 to the power of a half, okay, that 9 to the power of a half, I'll do that down here, is the same as the square root of 9, which is 3. So it should be 3 x to the power of 4, y to the power of 3 over 2. Okay, and that's my final answer. On to question 2. Okay, it says that in a sale, normal prices are reduced by 17%, which makes it a little bit bigger, and the normal price of the washing machine is reduced by £42.50. We want to work out the sale price of the washing machine. So, normal price is reduced by 70%, and it says that just use my highlighter, are reduced by 17%. It says the normal price of the washing machine is reduced by £14.50. That tells me that the information I've been given, that the 17% is equal to £42.50. Okay, it's been reduced by that. Once I've got to this point, I can start thinking about where I get back to. I'm going to find 100% because I think that's going to be useful for me. So let's go down to 1%. Okay, that's dividing by 17. So that means I need to divide by 17. Okay, and this is a calculator question. So £42.50 divided by 17, and I get 2.5 or £2.50. That means 100%, which is times it by 100. Ooh, my pen's not work there. Times by 100, so times this by 100. 100 times by 2.5 will be 250. Okay, so the original price was £250. I just need to double check the question. I need to check if I've answered the question. Okay, it says work out the sale price of the washing machine. Okay? The sale price. This isn't the sale price. The normal price is reduced by this much. So the sale price is 250 minus £42.50. Okay, which will give me, and again I can do this on the calculator, will give me £207.50. Okay, 207.50 is my answer for 3 marks there. Question 3, again, let me make this a little bit bigger for you. Okay, we want to describe the single transformation that maps A onto B. Okay, A onto B. Now for this question, we should notice A onto B that A has not rotated. And we know that so the orientation is the same. By orientation, I mean that this point is still in the same position relative to the rest of the shape for here. If the orientation is the same, that's going to tell us that it's a translation. Okay? A translation. And those are the ones that have a vector that's translated it. So if I want to describe the single transformation, I'm going to say it's a translation using the vector. And now I need to work it out. How many steps to the right has it gone? 1, 2, 3, 4. And I've counted from this bottom one, so I can mark it on here because it's going to help me. 1, 2, 3, 4. So 4 steps in the x direction. And then it's gone down 1, 2, 3. I need to make sure I go to the bottom one again, because if I go down 2 to here, I've not used the same point. So it's gone down 1, 2, 3. And because it's gone down, it's -3. So that's my answer for this one. A translation using the vector 4, -3. This question, similar to the work we've been doing this week on algebraic fractions, it says simplify fully for, let me just make this a little bit thinner, 4 over 2 minus x minus 3 over x. Okay. Now, anything with fractions need the denominators to be the same. The easiest way of me doing that is by multiplying, by going, right, this, I'm going to pop up, I'm going to go up there, we'll go up there, and then this will go up there. So, I will go 4 lots of x minus over, and then I know that this will be x, 2 minus x, minus 3 lots of 2 minus x over x, 2 minus x. I also, now I've got these two as the same denominator, I can write this as one fraction. 4 lots of x minus 3 lots of 2 minus x is the same as over x lots of 2 minus x. You notice every single time I'm writing a new line of working, every time I change one thing, I'm not trying to do it all at once, I'm just doing every single line of working differently. Now I'm going to expand my brackets because I know that on the top, because those aren't as simple as they could be. So 4 times by x is 4x minus, and on here I'd have negative 3 times by 2, which is negative 6. And then negative 3 times by negative x will be positive 3x. We need to be really careful about timesing those negatives. And that's all over x, lots of 2 minus x. Now again, I need to then simplify this top row. 4x plus 3x is 7x. Plus 6 all over x, lots of 2 minus x. Okay? And that is our answer. Easy as that. So, let's have a look at the next question. Question 5. We're told that m equals 1 over ps. Okay. And I'm told that this is correct to this. And I'm told that s equals 2.9. It's a 1 decimal place. And it says the upper bound for the value of m. Now, this is a bounds question. Keyword there is bounds. So 5.37 correct to 2 decimal places. So I'm going to go, right, the lower bound will be 5.365. The upper bound, 5.375. Okay, I'm going to draw, just going to put this down here so it's easy to see. Now s is 2.9. Lower bound, because it's correct to 1 decimal place, 2.85. Upper bound, 2.95. Okay, and that's a great start to our working. However, I now need to think really carefully. I need to work out what the upper bound of the value of m is. How do I make m as big as possible? Now, when I'm dividing, I know that the denominator needs to be as big as possible. Sorry, the denominator needs to be as small as possible to give me the biggest answer for m. Okay, so the way I get a big M is by this being small, PS. Okay. If I want PS, so I need PS to be small. To get PS to be small, I need to use the lower bound of P and the lower bound of S. That's how I get PS to be small. Now I want PS to be small, just to make it really clear. I want PS to be small because then I do 1 divided by a small number, and that will give me the upper bound of m. The upper bound of m. Okay. So, the lower bound of p times by the lower bound of s is what I need to do. So in my calculator, what I need to make sure I do is go, right, I need to go, okay, so 1 divided by p, the lower bound, which is 5.365, times by the lower bound of s, which is 2.85, and that will give me my, this calculation will give me my upper bound of n. So on my calculator, I'll type that in. And I get 0.654. Okay? So my final answer for this is that it's 0.0654. I think I missed the naught when I wrote it down here. Yeah, 0.0654. That's my final answer, and that's to 4 decimal places.